Welcome to Fascinating Frontiers, episode 69. Today is May 12th, 2026. Here's what's happening in space and science today. A supernova caught mid-explosion in a spiral galaxy offers a rare window into stellar death at 50 million light-years away. An amateur astronomer stacked more than 2 hours of images to capture SN2026 Kid exploding inside the edge-on spiral galaxy NGC 5907. The detection marks the observer's first supernova find and shows that even modest backyard setups can record genuine transient events in real time. At a distance of 50 million light-years, the explosion gives astronomers an unusually clear look at the final moments of a massive star. Such observations help refine models of stellar evolution and the triggers that lead to core collapse. The result also highlights how accessible equipment continues to fill gaps left by professional surveys that cannot monitor every galaxy continuously. On a different note, a new high-resolution portrait of the Pinwheel Galaxy, M101, has been released using ground-based gear. The image combines 4,173 seconds of exposures taken across multiple states with a small refractor and an unmodified DSLR camera. Spiral arms and active star-forming regions stand out clearly, even though the data came from sites chosen to limit light pollution in the American Southwest. This approach demonstrates that careful technique and longer total integration times can produce professional-grade deep sky results without specialized observatories. Observers gain fresh detail on how star formation propagates along the galaxy's arms, information that complements data from larger facilities. The work underscores how advances in consumer equipment and processing methods keep expanding what dedicated amateurs can contribute. Next up, an abandoned Falcon 9 upper stage has created a fresh crater on the lunar surface after an earlier mission. The second stage struck the moon at high speed, and orbiting spacecraft are now examining the resulting impact site. This unplanned event supplies direct data on how rocket hardware behaves during lunar collisions and how ejecta patterns form in the low-gravity environment. Studying the crater helps calibrate models used to interpret other impact features across the moon and similar bodies. The observation arrives at a useful time as mission planners prepare for more frequent landings in the coming decade. After that accidental experiment, attention turns to deliberate hardware testing for the ExoMars 2028 mission. Engineers at Theolanea Space have completed full-scale structural test models of both the rover and its carrier spacecraft. These replicas will undergo vibration, thermal, and load testing to verify designs before any flight hardware is placed at risk. Completing the models keeps the overall schedule aligned with the planned launch window in 2028. The process illustrates the careful qualification steps required for interplanetary missions, where repairs remain impossible. From European preparations for Mars, the focus shifts to NASA's longer-term plans for sustained operations on the Moon. The Artemis program is developing reusable landers, power systems, and habitat modules to support crews staying for months at a time. Planners emphasize incremental growth, building experience step by step rather than attempting permanent bases immediately. This architecture aims to create reliable logistics and living systems that can expand as capabilities mature. The approach reflects lessons from earlier programs about the value of repeated surface operations before scaling further. Engineers are also refining the next generation of spacesuits intended for those extended lunar stays and deeper space activities. The designs prioritize improved mobility, better dust resistance, and life support backpacks suited to longer exploration timelines. Suits must function reliably both on the lunar surface and during transit phases where conditions differ significantly. Iterative testing continues to balance protection with the flexibility astronauts need for practical tasks outside habitats. On a related note, the Artemis II crew has already demonstrated how liquids behave without gravity during their flight. Footage shows astronauts releasing a single droplet of water that formed a near-perfect sphere held together only by surface tension. The crew could poke, stretch, and split the droplet with surprising control, revealing behavior that gravity masks on Earth. These observations feed directly into the design of fuel tanks, water recycling systems, and medical equipment for future missions. Engineers are already applying the insights to refine droplet management inside closed-loop life support hardware. What remains less certain is how prolonged radiation exposure or cabin materials might gradually change those same surface tension properties over months in deep space. You know what is fascinating about this? Picture the International Space Station as a sealed room the size of a large house, yet every loose droplet inside behaves as though it were the only thing that matters. On Earth, a milliliter of water collapses under its own weight into a puddle. In orbit, the same volume is pulled inward from all directions by surface tension, until it becomes a near-perfect sphere, roughly the diameter of a grape. That sphere can grow or shrink simply by adding or removing tiny amounts of liquid, because nothing is pressing it against the surface. Astronauts have measured these droplets reaching several centimeters across before they merge or split, all while floating at speeds matching the station's 28,000 kilometers per hour around the planet. The same physics governs how fuel settles inside rocket tanks and how sweat behaves on an astronaut's skin during a spacewalk. Yet researchers still cannot fully predict how trace contaminants or prolonged radiation exposure will change the surface tension of these droplets over the course of a 6-month mission. From in-flight fluid experiments, the conversation moves to university teams contributing hardware and analysis for upcoming flights. Faculty and students at Arizona State University are supplying instruments and data analysis pipelines to several NASA and commercial spacecraft now in development. Their work centers on surface chemistry measurements, radiation monitoring, and autonomous navigation systems that will operate on future missions. These partnerships span both government and private vehicles, giving students direct experience with flight-qualified technology. The involvement strengthens ties between academic research and operational space programs. Finally, a third grader's artwork has been selected to fly aboard an upcoming SpaceX cargo mission to the International Space Station. The student's drawing from Apollo Beach, Florida, will travel alongside experiments and supplies already scheduled for the resupply flight. Such selections continue a long tradition of educational outreach that lets young people see their creations reach orbit. The gesture reinforces how spaceflight programs maintain connections with the public even as technical complexity grows. New hardware and observations keep revealing how little we still understand about operating far from Earth. Keep an eye on upcoming tests of surface chemistry instruments from university teams that could reshape how we interpret data from the next Mars and lunar landings. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.